Okay, we're continuing to look at differentiation, which is the process of finding the derivative. Remember, the derivative will give us, it's basically a function for the gradient of the tangent to a curve at any value for x. So we looked at several different rules for differentiation, and so I wanted to show you guys just a couple of other quick examples to help illustrate this point to you guys. So if you want to watch these, cool. If not, you're welcome to move on and take a look at the next section. So here, looking at this first one, we're going to take our 3, bump it down here, so we end up with 5 times 3, which gives us 15. And then with our exponent, we're going to do 3 minus 1, so that'll give us 15x squared as our derivative. Okay, looking at the next one, so here we have the difference of two terms. So we're just going to take these piece by piece or term by term. So we do the same process. So we take this 1 and bring it down here. We multiply it by 5, which gives us 5. Now this 1 is going to become 1 minus 1, which is 0. And we know that any number to the 0 power is going to be 1. So essentially what we end up with is 5 times 1 for this value. Here we're going to do the same process, so let's bring this 2 down here. 2 times this negative 1 gives us a negative 2, and this 2 exponent drops down to 1. So we end up with 5 minus 2x as our derivative. Look at the next one, same process again, drop the 3. So this will become 3 times x squared. Same process again, this will drop and become 4 times 1. X to the 0 power is going to be 1. So this comes out to be just 3x squared plus 4. Here, same thing again. This will be 4 times a half, which gives us 2. And drop the exponent 1, so that's x cubed. Here, remember we said our rules, any constant is going to drop to 0, so basically it's going to disappear. And then we use the same process with this x squared, bring the 2 down, we do 2 minus 1 gives us 2x as the derivative. Here we're going to do the same process that we've been doing, but let's get this x out of the denominator by bringing it up here and making it x to the negative first power. And when we do that, this negative 1 bumps out, so this ends up being, well, x, so we forgot to do x, so that's going to be x minus 1, which would be x to the 0 power, which is 1. That's where we get this. And then this is x to the negative first. Bring the negative 1 out here. And then when we subtract 1 from negative 1, we get negative 2 for our exponent. So here's our final product, the derivative. Okay, now on this one, we're going to follow the same rules again for letter G, except here let's split this. Instead of being x plus 1, let's make it x over x plus 1 over x. This one will move to the numerator and become x to the negative first. X over x is just 1, which makes this a constant, and so then when we take the derivative of 1, it's going to drop to 0. When we move this negative 1 down here, we also subtract 1, so we end up with negative x to the negative second as the derivative. And the last one, let's do the same thing. So let's split this up and make this x squared over x. When we do that, we can go ahead and simplify this, and it drops to just x. And then we take the derivative of x, bring this 1 down, and 1 minus 1 is the exponent, so that would be x to the 0 power, which is the same as 1. Here we have 5 over x. Let's move this x to the numerator. It's going to become x to the negative first times 5. And I'll follow the same process. 5 times negative 1 gives you negative 5. Negative 1 minus 1 gives you negative 2. So there's a few more examples for you. I hope that's helpful.